All right, guys, we're going to start with problem number 9, which is in module number 2. Should be at the top of page 4. All right. So top of page 4. First thing that I would do to solve this problem would be to distribute the 3 to each piece. So I'd have 3x minus 15 is less than 5x plus 9. Now, when I'm working with inequalities, I usually like to keep my x's over on the left-hand side because a lot of times they'll give me an answer line that looks like this, and I have to figure out how to fill it in. So I want to keep my x's on the left-hand side. So I'm going to subtract 5x from both sides. What is 3x minus 5x? Negative 2x. Bring down that negative 15, bring down my inequality, my little alligator mouth. And I have a 9 here. Then I'm going to add 15 to both sides. What is 9 plus 15? 24. So I have negative 2x, and then I have my alligator mouth, and 24. Here's where it gets a little bit tricky, because I'm going to divide both sides by negative 2, but anytime I divide or multiply by a negative number, what happens to my inequality right here? It switches, it flips around the other way. So instead of the alligator eating this side, now the alligator is eating this side. So I have x is greater than negative 12. If you were asked to graph this on a number line, negative 12 is right here. Would I use an open or a closed dot for this? I would use an open dot. I'll draw the smiley faces here in just a moment. Which way would I shade? To the right or to the left? To the right. Alligator eats the bigger thing, and X is the thing that I'm shading. So I'm going to shade this way. All right, so the smiley faces that we learned before, that I believe you guys know of from Algebra 1. Well, let me go back and fix that. We would choose a filled-in dot on our number line if we had that or equal to line underneath. If I'm graphing it on an XY axis, then I would graph that with a solid line. Since I just had the greater than, my original problem, I had a less than. When I do it on a number line, the nose on a number line is an open dot. Or if I were graphing this on an XY axis, I would choose a dashed line if I saw just a greater than or a less than. What else would you guys like to see or work through from the review? Number which one? Number 5, absolutely. All right, on number 5, this first graph that we're looking at here, does it go forever left and right? No, then it is non-continuous. It has to go forever to the left and to the right to be continuous. My domain, I'm looking at my x's. I want to know what's the farthest left it goes, and then what's the farthest right it goes. What's the farthest left this ever goes? 1. And what's the farthest right it ever goes? Infinity, because we have an arrow on the end of it right here. So from 1 to infinity. And I chose a square bracket because it is a filled in dot right there. I use parentheses when I can't or I'm not allowed to touch it. I can't touch infinity. It's not possible because infinity is an idea. This idea that it goes on and on and on and on and on. I can't actually touch it. If there was an open dot, I can get really close to it, but I'm not allowed to actually touch on the inside there. And then my range, I'm looking for the bottom. How far low does it go? And then I'm looking for the top. This goes with my y's. What's the lowest this graph ever goes? 2. What's the highest it ever goes? Infinity. We have an arrow on the end. It's not going up very fast, but it is going up. And that arrow on the end tells me it's going to keep going up forever. So this is going to be 2 to infinity. Bracket around the 2 because of that dot. Parenthesis around the infinity because I can't ever get there. Let's look at the one on the bottom here now. This parabola, does it go forever to the left and to the right? Yes. So this is continuous. And when it is continuous, that means my x-axis, since it goes forever left and right, negative infinity to positive infinity. My range, we're always going to do bottom to top, because it's always smallest to biggest. What's the lowest down this ever goes? What'd you say? Infinity, negative infinity because it's the bottom. What's the highest it ever goes? 1. I read this off of my y-axis because range is my y's. Can I actually go up to the top of this parabola with my pencil? Yes, bracket. What else would you guys like to see? Number 4? Absolutely. All right, we're going to graph 2 different functions in number 4. For the first one, it says we need to graph these using the x and the y-intercepts. To do the x-intercepts, well, I know an x-intercept always looks like this. It has a number in the x spot, and it has a 0 in the y spot, always. A y-intercept, it's switched around the other way. The 0 is in the x spot, and it's going to have a number where y belongs. So the way I use my x and y intercepts, the way I find them with my equation for the x-intercept, I'm going to look at the equation that they gave me, and I'm going to recopy it, but I'm going to make a substitution. Look at the way I said an x-intercept is written. Number and then 0. 0 in the place of which one? Is that the x or the y where the 0 is? Y. So over here in this equation, I'm going to put a 0 in the place where I see the y. So I have 2x plus 3, and then I'm going to put that 0 in for y, equals 12. What's 3 times 0? 0. So I have 2x plus 0 equals 12. If I'm minus 0 from both sides, what will I have over on the right? Still 12. 2x equals 12. How do I get x all by itself now? Divide both sides by 2. I get that x is 6. So that's the number that goes in right here. I want an ordered pair at 6, 0. So I put my dot down. If I'm looking for my x-intercept, I put 0 in the other spot. I leave x there if I want to find x. And I put 0 in for the other variable. So for my y-intercept, I should put 0 in the place of what? X. I put 0 in for the thing I'm not looking for. So for my y-intercept, I have 2, and then I'm putting a 0 in the place of x plus 3y equals 12. Well, what's 2 times 0? 0 plus 3y equals 12. What happens if I minus 0 from both sides? Stays the same. 3y equals 12. I want to get y all alone. So I'm going to divide both sides by 3. And I get that y is what? Y is 4. So at 0, 4, I'm going to put a point right here. And then how do I graph a line with those? Connect the dots. For part B, I want to put this in slope-intercept form so that I can graph it. I didn't want to do that on part A over here because part A said to use the x and y intercepts, but part B is very different. This is an inequality, so I'm thinking those faces again. And if this has helped you with graphing inequalities, you would want to make sure that these faces are something that goes on your cheat sheet. What do I need to do to this equation to get y all by itself? Subtract 1 from both sides. So I have y is less than 4x. And then is that 0? -2. So I'm going to go to -2 on my y-axis and put my first point down. That's my y-intercept. Where do I go from there after I get my y-intercept graphed? What'd you say? Not add 2. What's my slope? 4. So we're going to go up 4 and over to the right 1 because this denominator is a 1 under here. It's always rise over run. So I go up 4 and right 1. Up 4 and right 1. Up 4 and right 1. And then I go backwards with that exact same pattern. So down 4 and left 1. Down 4 and left 1. Should I do a dashed line or a solid line here? Dashed, why? Because we didn't have a line under our inequality originally. Absolutely correct. So it's this face right here. So we're going to do this. And there's one more thing that I have to think about on a problem like this when I have an inequality. What's the last thing I need to do here? Shade. I got to figure out which direction I'm shading. Do I shade this part up here? Or do I shade this part down here? I'm going to pick out a test point, and I'm going to see whether that test point comes back as a true thing or a false thing. Whatever point I pick out to test, if it comes back as true, I'm going to shade where that point is. And if it comes back as false, then I'm going to shade the other side. So I usually like to go with 0, 0 as my test point, because it's really easy to multiply things by 0. I'm going to recopy this original inequality down, only I'm going to put a 0 in the place of the x, and I'm going to put a 0 in the place of the y. So I have 0 plus 1 is less than 4 times 0 minus 1. What is 0 plus 1? 1. What is 4 times 0? 0. What is 0 minus 1? Negative 1. Is that true or is that false? Is 0 smaller than negative, or sorry, is 1 smaller than negative 1? No, this is false. So I would choose to shade the side of this line where 0, 0 is not. So this tells me do not shade where 0, 0 is. Well, which side is that, top or bottom? Shade or do not shade this side? Don't shade. So this side, shade or do not shade? Shade. Somebody asked me last period when we did this exact same problem, do you always have to use 0, 0 for your test point? No, you don't. I usually like to pick double numbers though. You never pick a number that is actually on your line. Because if you pick something that's on the line and you say, well, do I shade this side or this side? You're like, I don't know, you're on the line. So you want to pick something that's not on your line so you can see whether it's true or false and you know whether to shade it or not shade it. But you could pick out any other spot, like if I decided to test like 10, 10. 10, 10 would be right up here, right? Well, let's see what happens. Is that in our shaded space right now? Yeah, so I should get back something that's true, because that means I'm supposed to shade it there. Well, let's see what happens. I'm coming back up here. I'm going to recopy this original inequality, but I'm going to put a 10 in the place of the x, and I'm going to put a 10 in the place of the y. So I have 10 plus 1 over on the left is less than 4 times 10 minus 1 on the right. What is 10 plus 1? 11. What is 4 times 10? 40. Minus 1. What's 40 minus 1? 39. Is 11 less than 39? Yes, that is true. Shade where 10, 10 is. So you can pick anywhere as your test point. It doesn't have to be 0, 0. I just like 0, 0 because I make less mistakes when I use 0, 0. What other problems would you guys like to see? 14? Absolutely. Number 14, first thing I'm going to look for is my zeros. Where do I look on the graph for zeros? Give me synonyms. X-intercepts. What's another synonym? Solutions, roots. Zeros, x-intercepts, roots, solutions. So I'm looking for where it crosses the x-axis. So right here and right here. The one on the left, where's that at? -2. So x equals -2. And x equals what? 4. My vertex, this is either going to be the very lowest point, like the bottom of the valley, or the very highest point. It's either a minimum or a maximum. Do you guys see either a minimum or a maximum? Which one is it, minimum or max? Minimum. This guy right down here. What would be the ordered pair to describe that point? 1 and, you said 1, 9? 1 and -9, yes. 1, -9. My y-intercept, if my zeros are my x-intercepts, my y-intercept would be where? Same spot? Y-axis, -8. Technically, I should probably write that as the ordered pair 0, -8. But if you just wrote -8 on your test, I would not count that as wrong. And then last but not least, I need my axis of symmetry. Which way does the axis of symmetry go? Up and down or left and right? Up and down. And it needs to cut my parabola in half. Where's it going to go through to cut my parabola in half? -1 over here. +1 right here. And what axis am I going through when I cut that parabola in half? I went through the x-axis, and so I have to put that on here so that my reader understands that. I have to say I went through the x-axis at 1. So x equals 1. What else would you guys like to see? $15? Absolutely. $15, we're going to do some factoring here. How many terms does the first one have? Just 2 terms. This is one of those special situations. This is a difference of 2 squares. When I have only 2 terms, I have a minus in between and only one of them has an x with it. One of them has an x squared and the other one doesn't have any x's at all. I stop and I ask myself, what would I multiply by itself to get 4x squared? 2x. So both of my factors get a 2x with them. What would I multiply by itself and get 25? 5. But that's not just 25, that's -25. 1 positive, 1 negative. Those are my factors. 2x plus 5, 2x minus 5. How do I find the solutions now? What are synonyms for solutions again? Roots, x-intercepts, solutions, zeros. What do I want to do with my factors? Set them equal to 0. So for one of them, I'm going to have to minus 5 from both sides. I get 2x equals -5. And then I divide both sides by 2. There's my solution. X equals -5/2. For the other one, I have to add 5 to both sides. 2x equals 5. Divide both sides by 2. So the other one is +5/2. X equals 5/2. For the one in the middle, how many terms do we have? I've got 3 terms. How do I do something if I've got 3 terms? I can't use the same trick. What do I need to draw? A box and an X because I only have 3 terms. When do I draw the box but no X? When I have 4 terms, because my box has 4 little spots in it. What goes up here in the upper left? X squared. What goes in the lower right? -12. I have to multiply A and C together. So 1 times -12. I need 2 numbers that times together to give me -12. But when I add those same 2 numbers, I get what? I get 4x. I get 4. Well, what multiplies to -12 but adds to +4? 6 and -2. So 6x, -2x. All right, 2 boxes at a time now. Looking at just the top 2. What do they have in common? What can go into both of them? X. Looking at the bottom 2. -2. Then I switch and I go the other way. X squared, -2x. What do they have in common? What's the same? X. And then right here, 6x and -12. What can go into both of those? 6 can go into both of those. Positive or -6? +6. So x minus 2, x plus 6. Why is it +6? Who can explain? It's next to a box that's a positive. It's touching this box right below it. And that 6x is a positive. Over here, I had a -2x that it was touching. And so that's why my negative sign comes out there. So those are my factors. How do I find my solutions? Set them equal to 0. So I get that x is 2. And I get that x is -6. All right, we got one more to do together on this one. How many terms? 3. So how do I solve it? What do I do? X box. Draw the box first. And then draw the X. Two x squared up here. And -6 down here. So I have to multiply those 2 together. So I'm multiplying 2 and -6. What is 2 times -6? Negative 12. I need two numbers that when I times them together, I get negative 12. So start thinking of your negative 12s again. What about when I add them? Negative 1. Is this negative x? There's an invisible 1 right there. It's a negative 1x. What two numbers do you know of that will multiply to give you negative 12, but when you take those same two numbers and add them, they add up to negative 1? I heard 3 and negative 4. So 3x, negative 4x. Two at a time now. Across the top. Do 2 and 3 have anything in common? No. What about 2x squared and 3x? Do they have anything in common? X. Down on the bottom, negative 4x and negative 6. Can negative 4 go into 6? It can go in one time, but it doesn't go in a whole number of times, right? Can 6 go into negative 4? No. What number can go into both of them, though? 1 and 2. Remember, I want the biggest thing, so I'm going to go with 2. Will it be a positive 2 or a negative 2? Negative 2. Pulling this negative out right here. So x minus 2. And then I'm going to go vertically. 2x squared and negative 4x. I see that they have an x in common. Do they have anything else that'll go into both of them? 2. So 2x. And then I'm going to go vertically like this over here. 3x and negative 6. Can 6 go into 3? Can 3 go into 6? That's going to be my biggest one then. Positive or negative 3? Positive, because the box right below it is a positive right there. All right. Let's find our solutions now by setting them equal to 0. One of them I get is a positive 2. And the other one, I have to subtract 3 from both sides first. So 2x equals negative 3. Divide both sides by 2. And x equals negative 3 over 2. What would negative 3 over 2 be as a decimal? Negative 1.5. Absolutely correct. All right, we've got about 3.5 minutes left, which is enough time for me to do one very, very short one, or I can give you guys a little bit of independent time right now. What would you prefer? Number 13, let me see if I have time to do that. Oh yeah, we definitely have time to do this. I want to know whether or not these are solutions. So it needs to be in the shaded space. Not on a dashed line. If it's on a dashed line, it does not count. So 0, 0, would that count as a solution? Yes. 2, 3, right here. Would that one be a solution? No, why not? On a dashed line. Zero, 2. Let's go look at that one. Is that one a solution? Yes, it is on a solid line. One, 0. What do we think? No, why not? On a dashed line. 2, 1. No, why not? It's not on a dashed line. It's not in the shaded region. -6, -1.5. Yes. All right. Bell rings in less than a minute now, so I'm going to time us out here. I'll continue to take any questions you guys have tomorrow, Monday, and Tuesday. I see you guys all 3 days for a full regular class period, so I'll take questions all 3 days. I did do different questions in 4th period and 5th period, and I'm posting the videos. The audio is what's worthwhile, because the video quality is not always catching when I write on the screen. But I will post the work that I did for the other problems and the audio that goes along with them. Yes, sir.
Like actual lines, like the lines off the dash line, those actually mean solutions.
If it's touching the shaded space and on the line, yes. Now, if it was over here, then no. But if it's touching the space that's shaded and it's on a solid line, yes, that counts. Those are solutions, yes. Have a great one, everybody. I'll see you guys tomorrow.